Okay, so I have a question.
Yes.
After the rope snaps, right?
Yes.
The 4 kg block is still on the surface.
Yes.
So won't we have
will.
normal force?
We will have the normal force. We will definitely have the normal force. Any other force? Romeo, do we have any other force? Okay. There's no completely. Now, we have to choose our directions. I'm going to choose downwards and that direction is positive. Okay, so when I resolve, if I'm resolving, let me write it properly. This is 30 degrees, by the way. If I'm resolving in this direction, I'm gonna have what is it that I'm gonna have? I'm gonna have mg, which is force of gravity, sine of 30. Do you agree with that force? The component.
Yes, sir.
Okay. It's just that I didn't write fg, but it's the same thing. And then I'm gonna have minus friction, which is going in the opposite direction. Yes, in the opposite direction. So it will be equals to mass times acceleration. Remember, the acceleration is going to be new because now we have a new system because the rope has snapped. So what we're going to have is 4 times 9,8 times sine of 30 minus, what will be the value of friction? Romeo. It will be Mamsan, what would be the value of friction?
So will it not be negative 0.18 multiplied by mg? Wait. Cos 30. So will it not be negative 6.11?
It is. It is. Okay, so basically, I was just going to take this thing. This is our friction. Just that I didn't calculate it separately, but now I want to calculate it separately. Times the normal force. Force was 30. What was the normal force? 33.948. And it gave you 6.11, right? 1 newtons. Okay. So I'm gonna put it here. Equals to mass, which is 4, times acceleration is in the positive direction. That's gonna be A. Okay. So now, what do we get here? What do we get? Did you get
19.6.
Okay, 19.6 minus 6.111, right?
Yes.
Okay, so this will be 13.489 is equals to 4a. Then if we divide by 4, our acceleration will be 3.372. I don't know if I got the answer right. Okay. Okay, now if we have that as an answer, let me insert a page. Another one. And another one. Okay. And what is the units of acceleration? Meters per second square. Okay. Which equation can I use from the equation of motion? Mamswan. To determine, yes.
So you could use delta x is equals to vi delta t plus half.
Yeah, which is 5 meters, right? Okay. So delta equals vi t plus 1 over 2 acceleration times time, right? Okay. So you agree that this is 5 and this is v initial was 0. You agree?
Yes.
Ronne, what do you agree? Do you agree that v initial was 0? We assumed that just before the snapping, the object was at rest. So this will be 3.372 times time, which is what we are looking for. So 1.686 t squared is equals to 5. By divide by 1.686, 1.686 t squared equals 2.966, and t equals plus or minus the square root of 2.966, which is 1.722 seconds. But we're gonna rub off the plus or minus because we are dealing with time. Okay. 1 point. Any question on this one? I think this was easy because it's a question of motion. Okay. Then the second one, I would give it to you if you use any height. If you use any height, I would give it to you. But the height that I've used myself was 5. If this is 5 and the angle here is 30, what is the height here? Because I assumed that the two objects are at the same height just before the snapping. I assumed that if I get that height, it will be the same as that one. So what will be the value of height in this case? Mamswan.
So what would the value of height be?
Yes.
Yeah, okay. So it's gonna be sine theta sine. Is it sine? Yeah, sine 30 equals to h over 5, and then equals to sine 30 times 5. So will it not be 2.5
Yeah, 2.5 meters.
meters? Yes.
But does it look reasonable, the 2.5?
No.
It doesn't.
Mm-mm.
But remember, okay, did you expect the height to be greater than this portion?
Not greater, but I expected it to be like 3 or something. Or yeah, 3.
To be 3.
Yes.
But it wasn't gonna suffice, it wasn't gonna match with the core ratio of sine. Sine of 30 is 0.5. You agree?
Yes, sir.
So this should be the half of that one.
Okay.
It's just that it is what it is. But because three won't suffice. So if I use 2.5, again, it's gonna be the same thing. Change in y equals vi, change in t plus is the formula that you gave me initially. So this will be 2.5 equals 0 plus 1 over 2 into acceleration. So what would be my acceleration? Ronel, on the 6 kg block, what will be my acceleration after the snapping? What will be the acceleration of the 6 kg? Mamswan, what will be the value of acceleration?
So would not be the one we calculated?
No, it won't be.
Will it not be half of that?
No.
Yeah, then I don't know.
Do you agree that after snapping, the 6 kg block will be on a free fall? Do you agree?
Yes, sir.
So if an object is in a free fall, what is the acceleration?
I don't know.
Taibo.
So I thought it was that, but then in my head we're not doing Newton's gravitation, so I was like,
No, if an object is on a free fall, the acceleration is 9.8. That's the gravitational acceleration of any object on Earth. Okay, then we have T. Yes. So I beg that you must go and revise this question for the second time because you might get something similar in the exam. Okay, so 2.5 equals let me see. I got 4.9 t squared. Then t squared equals, if I divide both sides by 4.9, I'll get t squared equals 0.51, and t equals the square root of 0.51, which is 0.714 seconds. So the 6 kg will fall to the ground before the 4 kg, which makes sense because the 4 kg is resting on on a surface which has friction. So it's going to take time for it to okay. Question 2. Okay, question 2. I think this was the hardest, but you were getting most of these questions. Question 2, let me make a screenshot. Question 2. Okay. I go. Okay. Um, okay, so question 2. Fine. Two charged spheres of the same magnitude but opposite direction were placed at a distance of 100 meters apart. Now the force between the two charges is 50 newtons. So this is a force problem. So F 2.1, F is given by K Q1 Q2 over R squared. And this is, okay, this is going to be F, this is going to be, what is the value of F, Mamswan?
50.
50.
Yes.
Okay. I beg to differ.
Why?
Because, okay, are the two charges going to be in attraction, or are they going to be repelling each other?
So please go back, like scroll up so I can see the question.
Two charged spheres of the same magnitude but opposite direction.
So they're going to attract.
They will be attracting each other.
Yes.
So what is the typical sign of the force when two objects are in attraction? Is it
50.
positive or negative?
It's negative, sir.
It's negative because it will be plus times minus. You agree? Okay. It will be plus then minus. But I know, unfortunately, I think you might get the same answer even if you use a positive. But I just wanted you to be very careful with the signs. Okay, minus 50 is given by minus 9 comma it will give us minus. The reason why I said it's going to be a minus is because I know that the two charges when you multiply the product of the two charges, it will give you a minus. So I agree, even if you use positive here, you're going to get the same answer. Then times 10 to the power of 11. Wait, is it 10 to the power of, no, it's 10 to the power of 9, right? If I'm not mistaken. The value of K.
Yes, so it's 10 to the power of 9.
Okay. And then Q times Q, because they are the same magnitude, it will be Q squared. You agree?
Yes.
Then over our R was 0.1 squared. So Q squared, no, let me say minus, let me say 50 is equals to, if you divide these two, you will get 9 times 10 to the power of 11. I don't know if you got that. Okay, Q2. Then if you divide both sides by 9 times 10 to the power of 11, 9 times 10 to the power of 11, Q 50 divided by 9 times 10 to the power 11 will give us 5,556 times 10 to the power minus 11 is equals to Q2. Now, if I find the square root, I will get 7,45 times 10 to the power of minus 6 coulombs. I think both of you got this one right. So the answer is 7.45 coulomb and microcoulomb and 7.45 microcoulomb negative. These are the two charges. I think both of you got it. Okay, and then the next question says, if the sphere are brought together and then separated, what will be the new charge of each sphere? So the new charge Q new will be Q1 plus Q2 over 2, which is 7.45 times 10 to the power of minus 6 plus 7.45 times 10 to the power of minus 6 all over 2. So what will be the answer, Mamsan?
0.
The 0.
Mm.
Yeah, I agree. Okay, so Q, change in Q will be Q final minus Q initial. Q final is 0 minus Q initial was minus 7.45 times 10 to the power of minus 6, which is 7.45 times 10 to the power of minus 6 coulomb of electrons transferred. That was easy. And 2.3 Coulomb's law. Coulomb state that electrostatic force, is directly proportional to M1, M2, and inversely proportional to 1 over the square of the distance of their centers. It's fine. And then charge quantization. Charge, let me see if you wrote the same thing. Charge quantization talks about the multiples. You can write pockets, you can write a bucket, you can write a group, anything. So quantization. Quantization talks about the multiple of a unit charge, which is 1.6 times 10 to the power of minus 19. You can write it in whatever way. So many ways to explain quantization. So I'm not gonna dwell much in it. Okay. I see Ronewa didn't get the last question. Okay, no problem. Let's go to the next one. I think this was the hardest, right? 2.3.3. It was the hardest. It should be the hardest. No problem. Okay.
I ended up giving up.
Is it?
I gave up on this question.
Okay, no, I'm going to make it very easy. Two charged spheres, X and Y, are located 100 meters apart. I'm going to draw them. X, Y. Okay. And then, if the force between them is 5 times 10 to the power of minus 4, and the net electric field halfway between the two spheres is 8 times 10 to the power of 4 towards sphere Y. Define Coulomb's law, we've done that. Charge quantization, we've done that. Calculate the magnitude of charge of the charges on both spheres. Okay, yeah, that should be hard. Okay, first of all, we know The force, we were told that there's a force between them. Right? And what is the magnitude of force between them?
Five times 10 to the power negative 4.
Yes, and then this would be 9 times 10 to the power of 9 times x and y. Okay. Something that you must notice, ne? Okay, over r squared, which is 0.1 squared, right? Okay, do you agree with 0.1? Because this is in meters, not in millimeters. You agree?
Yes.
Okay. This is if we assume that x and y are are like charges. Do you agree? If x and y are like charges, for instance, if x and y are both positive, the value of the force will be positive, this one. Do you agree? Positive times positive is positive. And also, even if they are negative, negative times negative will give us a positive. So the only time this force will be positive is when we are talking about a repulsion. This is the repulsion case. We have two cases. We're going to have to solve two cases. The first case is the repulsion case. Okay, after solving the repulsion case, I am going to make x the subject of the formula. So in order, let me see what we have. So after solving, I got 5 times 10 to the power of minus 4 is equals to 9 times 10 to the power of 11 x, y. Now to make x the subject of the formula, I'm going to multiply by 9 times 10 to the power of 11 y, both sides. 9 times 10 to the power of 11. Y and y will cancel, and these two will cancel. I'm going to be left with x. Now, if I divide this expression divided by that one, I got 5.556 times 10 to the power of minus 16 divided by, I had to divide both sides by 9 times 10 to the power of 11 y. I forgot the y. So I will have that expression divided by y is equal to x. And I'm going to call that equation number 1. Okay. Now that I have two variables, y and x, I need another equation. So the other equation, I'm going to get it on the electric field. We have been told that the electric field, we have been told that we know that the electric field, total electric field, is given by the electric field produced by X plus the electric field produced by Y. Does this make sense? Roneo. Let me go back to where we were. We were here. So if I put an object midway, this sphere will produce an electric field. It will have its field, and this one also, it will have its own field. And the total electric field on that point will be the electric field coming from this sphere and the electric field coming from this one. Do you agree? Mamswan? The total electric field that is exerted on this charge. It will be the electric field exerted by this one plus the electric field exerted by this one. That is why when you draw your electric field, this is how it looks normally. Are you guys still there? Mamswan? Are you still there? Are you still there? Okay. Ronel, are you still there? So the total electric field was 8 times 10 to the power of 4, which was going to the right or in the direction of y. So if I choose that direction as positive, I will have 8 times 10 to the power of 4 is equals to the first electric field, the first electric field produced by X. If I assume that the two are in repulsion, I will say that Q of X plus KQY over R squared. So this will be equals to 9 times 10 to the power of 9 times our Q is X over halfway will be 0.05. Plus, for the y, it will be the same thing times y over 0.05 squared. Mamswan, do you understand why our R is 0.05? It is 0.05 because the distance between the two charges is 100 millimeters. So halfway will be 50 millimeters. This will be 50 millimeters from this charge and also 50 millimeters from this one. So we will have 8 times 10 to the power of 4 is equals to If you divide the 2, you will get before I divide, I want to replace the value of x. We know that from equation 1, x is given by that. So I will have 9 times 10 to the power of 9 all over 0.05 squared times, in place of x, I'm going to put 5.556 times 10 to the power of minus 16 all over y. Now I have successfully eliminated x in this equation. I'm only left with y. 9 times 10 to the power of 9 times y divided by 0.05 squared. Okay, from here, I want to eliminate, let me see what we have. So I have 8 times 10 to the power of 4 equals, if I divide all the numbers, I will be left with 2 times 10 to the power of minus 3 y plus 3.6. If I divide these two, 3.6 times 10 to the power of 12 y. So if I have this equation, in order for us to solve for y, I'm going to have to multiply by y on all the terms. Multiplying by y, multiplied by y. So 8 times 10 to the power of 4 y is equals to 2 times the y, and the y will cancel, 2 times 10 to the power of minus 3 plus 3.6 times 10 to the power of 12 y squared. Okay, let's see. Mamswan, how can we solve for y if we have the following equation? We will have 0. I'm just going to take this portion to the other side. To be 3.6 times 10 to the power of 12 y squared minus 8 times 10 to the power of 4 plus, it has a y, plus 2 times 10 to the power of minus 3. Now we're going to use a quadratic equation, because we have a quadratic equation. Okay, so y will be equals to minus the value of b is minus 8 times 10 to the power of 4 plus or minus the square root of minus 8 times 10 to the power of 4 squared minus 4 times the value of a is 3 0.6 times 10 to the power of 12 and times 2 times 10 to the power of minus 3 divided by 2 times A is 3,6 times 10 to the power of 12. Okay, so the value of y is given by so negative times negative will be positive. It will be 8 times 10 to the power of 4 plus or minus the square root. If you solve for what is in the square root, you will get the square root of 2.24 times 10 to the power of 10 divided by 7.2 times 10 to the power of 12. So can we solve this equation? Mamswan, is it solvable? Ranewa, can we solve for the value of y? Is it solvable? Okay, Mamswan, can you type the square root of 2.24 times 10 to the power of 10? How much do you get? Mamswan, how much did you get? The square root of minus 2.24? Ronel, what is the square root of minus 2.24 times 10 to the power of 10? If you type this portion, it will give you an error. 8 times 10 to the power of 4, plus or minus an error. Divided by 7.2 times 10 to the power of 12. So our first assumption was that we are dealing with two like charges. Because we are getting an error, automatically we know that the two charges are not like charges. Are you guys still there? Mamsan? Are you guys still there? Ronel, are you still there? Ronel, are you still there? Run them. Are you guys still there? Okay, perfect. Now, the two charges are not like charges. Therefore, I'm giving you guys a homework. Since we have proven that the two charges are not like charges, if you I want you to go back and follow the same process. The only thing that you need to choose, the only thing that you need to change is this value. Because initially I said it's a positive 5 times 10 to the power of minus 4. Go and change it and make it a minus and see what you're gonna get. Let's just do it, it's fine. If I change it, I'm just gonna take this whole thing. But if I change it and make it a negative, this whole thing will be a negative. So I'm gonna do another trial using a negative of that statement. So minus 5.556. Okay. In attraction, i.e. unlike charges, x will be equals to 5.556 times 10 to the power of 16 over y, but it will be a minus instead of a plus. So if I take where is that statement? I can even start from here. I will have 8 times 10 to the power of 4 is equals to what is it? It's equals to 9 times 10 to the power of 9. 9 times 10 to the power of 9 divided by 9 to the power of 9 divided by 0.05. 0.05. And instead of replacing x with a positive, this expression, I will replace it with a minus 5.556 times 10 to the power of minus 16, all divided by y, and plus other portion will be 9 times 10 to the power of 9. 9 times 10 to the power of 9 divided by 0.05 squared times y. So we will have 8 times 10 to the power of 4 is equals to, if you resolve this whole thing, you're gonna have the same number, but it will be the same number as what we have got, which is 2 times 10 to the power of 3, but it will be a minus. Minus 2 times 10 to the power minus 3. And then plus will be the same, plus 3.6 times 10 to the power of 10 to the power of 12. 12, this will be y, and this will be divided by y. Again, I will multiply by y in order to get rid of y that is in the denominator. I will multiply by y on all the terms. So y and y will cancel. Then I'll be left with 8 times 10 to the power of 4y is equals to minus 2 times 10 to the power of minus 3 plus 3.6 times 10 to the power of 12 y squared. Again, I'm going to take this portion to the other side. I will have 0 equals 3.6 times 10 to the power of 12 y squared minus 8 times 10 to the power of 4 y minus 2 times 10 to the power of minus 3. So if I'm using the quadratic equation, I will have y equals minus b, and minus b will be minus 8 times 10 to the power of 4 plus or minus the square root of b is minus 8 times 10 to the power of 4 square minus 4 times a will be 3.6 times 10 to the power of 12, and the value of c will be minus 2 times 10 to the power of minus 3. So immediately you can see that here we will have a minus times a minus, which will give us a positive. And all over 2a, which is 2 times 3.6 times 10 to the power of 12. So this gave me 8 times 10 to the power of 4 plus or minus the square root of 3.52 times 10 to the power of 10 all over 7.2 times 10 to the power of 12. The square root is positive, so surely we will get a positive answer. So the value of y was 8 times 10 to the power 4 plus or minus. I got 18,761.6 all divided by 7.2 times 10 to the power of 12. As you can see, I'm going to have two values of y. Y is equals to, the first one was 2,676.16.6 divided by 7.2 times 10 to the power of 12, or minus 107,616.6 divided by 7.2 times 10 to the power of 12. So the value that I'm getting was 3.7 times 10 to the power of minus 8 coulombs, or minus 1.5 times 10 to the power of minus 8 coulombs. Now, the value of x is given by this portion here. So I'm just going to replace x will be, it will be 5 minus 5 by 5, 6 times 10 to the power of minus 16 divided by the value of y, which is 3.7 times 10 to the power of minus 8. So this gave me minus 1.5 times 10 to the power of minus 8. Or I'll do the same, this one, 5.556 times 10 to the power of minus 16 divided by 1.5 times 10 to the power of minus 8. So this gave me 3. The answer, it was a negative minus 1.5. Sorry. So the answer that I got was 3.7 times 10 to the power of 8. Sorry, not 8, minus 8. So yes. So the two charges are y equals 1.5 minus 1.5 times 10 to the power of minus 8. And x will be 3.7 times 10 to the power of minus 8. So how did we come up with this solution? What we were told is that, you see where the question is. Question said, the electric field halfway between two spheres is 8 times 10 to the power of 4 towards y. So if this is y and this is x, y should be negative because the electric field lines move from positive to the negative. And we have calculated and find out that we have two unlike charges, which are minus 1.5 and 3.7. So these are the values that we got. So in order to, I just want to do a quick verification. It said the value of force is 9 times 10 to the power of 9 times, I just want to multiply the two charges and see. Divided by 0.1. Can someone use a calculator? I just want to see. I just want to verify. Rondewa, can you hear me? Okay, so we have 9 times 10 to the power of 9 times minus 1.5 times 3.7 times 10 to the power of minus 8 times 10 to the power of minus 8 divided by 1 squared. And the answer turned out to be a minus 5. You see, 5 times 10 to the power of 1, 2, 3. 5 times 10 to the power of minus 4 newtons. Let me see if it corresponds to what we were given. Yes, it does. So I have successfully verified my answer. So these were the solutions. Y is minus 1.5 times 10 to the power of minus 8, and X is 3.7 times 10 to the power of minus 8. You can also go and verify these solutions. You can also go and calculate the value of the net force and see if it is going to be correct or not. Are you guys still there? Ranel, Mamsa. Okay. I think this will be the end of our lesson. So I will see you guys on Thursday. I'll see you guys on Thursday. All right, cheers.